and we covered the basic commands here. And so for today, we are going to. Uh, so yeah, first let's start with a few of the, I mean, the important files and everything. So first of all, let's discuss about home. So if you go to the terminal and right now, if you do pwd, you'll be shown slash home slash x117. So basically, even if you switch to some other user, I hope you all remember the yeah command. I mean the su command. Su command is used to switch to other users, and yeah, we are already inside the shell of the other user. And if you do, oh, okay, sorry, you won't directly get in here, but the thing is, yeah, just a minute. Yeah. So first of all, what we were going to discuss about is the home directory. So the home directory basically contains all the users with a shell, right? So if you do an ls, and right now there's only x117 because I'm the only user in my own system. The for the ones who are using the for the ones who are using the, I mean, could you scale up the terminal window text? Yeah, sure. I think it's visible now. Um, for the ones who are using the online ID, I mean the online, how many of you are using the VirtualBox or VMware or anything today, and how many of you are actually using the online one? VM. Anyone using the online one? Online. Jetobrata Chatterjee. Jetobrata Chatterjee, can you do one thing? Can you do cd slash home and tell me the output of that command? You might remember cd slash home, sorry, ls slash home. Ls slash home is basically, it shows the files and directories inside the slash home directory. Jyotobrata Acharya. No such file directory. Okay. Okay, that's really sad. But see, the thing is, let's say you are inside a system where multiple users exist and a number of users are, uh, I mean, simultaneously they are utilizing the terminal, utilizing that particular computer, either directly or remotely. Then you might have more than one users for that terminal. Even in Windows, you might have seen there's admin login, and then there's some other forms of I mean, multiple users can use a particular system. So you have the C, you have the path C slash users in Windows. The home is similar to that path. So basically, the home contains, I mean, all the directories with name as the names of the users. So for every user, for let's say for a particular user called user one, home will contain user one directory. Uh, and for user 2 it will contain user 2 directory, and these user 1, user 2 directories, etc., contain the different, I mean, the the different contents for each of the users. For example, if I go to, for example, right now I'm at home, and so if I go to simply cd is simply cd2x117, we can see. And if I ls now, first of all, you might have observed that when we do a pwd, we are shown the whole path. But in case when we are doing we are directly entering to this particular location, cd home slash x117. The prompt just shows this much. So the advantage of this is, I mean, one of the important things about the home directory for a particular user is, you can be wherever you want. Okay, you can just be in, let's say, sorry, desktop session, anywhere you want. And from here, you don't have to keep doing cd dot dot and everything. You simply have to do cd tilde, and as soon as you do it, you come back to home. So that's the advantage of, that's one of the advantages that they provide you for any particular user. If you want to go to your own home directory, you just have to do cd tilde and you are here. And from the home directory itself, you can navigate to the desktop and everything. So you won't have to write slash home slash x117 slash desktop and everything. You can simply do a tilde, and then from there you can directly navigate to the different portion. So if you ls inside home, you'll have a lot of yes, I mean, for example, one of the few of the important things are the desktop, the documents, the downloads and everything. Please don't look at the file names that I have here. I'm really sorry about it, but yeah, the desktop, documents and downloads and everything. So for the desktop, I mean, this desktop is exclusively for the user X117. Now, if there's a different user, that particular person will have a different desktop, different files inside the desktop, different documents folder, different downloads folders. So that's the thing. So basically, the home contains uh, the personal information, the whatever is contained by the that particular user. So the home directory, is it clear? Hello. Yes, right. So it'll be better if you see some sort of I mean, you people, I don't think you have attended any of the offline classes. So when we used to do that in the first year, we had to SSH into a computer. We had to SSH into a remote computer, and then we had to, submit our programs and everything. And yeah, exactly. Abhirup remembers. So what we had to do was, uh, we all were different users in that one particular computer. I don't remember the IP right now. I think it was 10.10.1.40 or something. We all of us had to SSH as different users, and if you went to the home directory there, you could have seen all the different users at that time. So that's the thing. That's about home directory. And then I think I discussed the last time about dot files. So basically, if you have a dot file here, I mean, right now, let's just move to the session one, cd desktop session. And if you do an ls stack a here, you'll see there's a file called dot hidden, which is not being shown in the normal file structure right here. I mean, this is the session folder only, which I have opened, and the dot session file, I mean the dot hidden file, is not being shown here because it starts with a dot. So if you have any files which start with a dot, it won't be shown in the normal structure. Even if you do a normal ls, that particular file won't be shown here. Even the dot and the dot dot are not being shown here. You might remember from the last session, dot is the present directory, dot dot is the parent directory. So with respect to slash desktop slash session, if you do cd dot dot, you will reach the desktop because that's the parent directory of session, right? So that's about the dot files. There's nothing more to do. Dev null is a really important file on Linux. Dev null is often treated as the black hole in a Linux system. Why do we call it a black hole? Because dev null eats everything. I mean, you can't contain anything in dev null. For example, if you do cat dev null, you'll get an empty output, right? You won't get anything. Cat, as you might remember, cat is basically the command to show whatever's inside a particular file. Okay, that's a really long file, basic. Yeah, this is a basic.txt file. As you can see, the cat command has displayed whatever's inside the file. So if you do cat on dev null, you won't see anything. You'll see an empty file. And the interesting part about dev null is that for every other file, let's say, what other files do we have? We have process.c. We have process.c. For example, if you simply cat out process.c, you'll see this is a file. So what I'll do is I'll simply add a comment here. Echo comment. Yeah, and I'll append it. You might remember, if it's a single greater than symbol, it will simply delete whatever's inside the file and then overwrite it. But if we do a double at the double greater than symbol, it will append to the end of the file. So what we'll do is we'll just append this comment at the end of the file. So here we go. And now if we try to see what's okay, sorry, process.c, you see that the comment has been added here. But if we try to do the same thing with dev null, you might expect that instead of the empty file, it will return you something. It will return you something which contains slash comment. But again, if I do cat dev null, you see it's empty. So dev null is like the black hole of the Linux system, and nothing can be appended. Like whatever you put inside dev null, it gets eaten up. Like it doesn't exist. So you can redirect anything to the dev null to. So if you don't want the output to exist, now you might think that what is the advantage of this particular file dev null? I'll just run a few commands and then you'll understand. So this is the file. First of all, let me run this command. I don't know whether it will be what I'm expecting or not, but let's just still run it. Control Shift V and we run it. I think you can appreciate the amount of output that's coming out here right now. Why is it coming out? Because there are hundreds of permission denied files. Right now, I am not root, and there are a lot of files which I don't have any access to, hence, I'll get all the permission denied. Now, I change this command. And now, even now, the output is not fully complete. It's fine. I mean, that's not a problem because this program might take some time because this particular program is looking for all the SUID files. We'll explain what SUID files later in the whole system, so that will obviously take some time. Yeah, it's complete right now, but I think you can appreciate the amount of output that's here. So going through this much of output and most of them being permission denied is going to be a really troublesome job. So instead of running this command, if you press the I mean the top arrow key, you'll see the previous command. I think you all might remember. Instead of using this command, what I'll do is I'll redirect the errors to the dev null and now run it. As you can see, the amount of output has decreased drastically. Why? Because we have redirected everything. We have redirected whatever errors we are getting to the dev null, and as a result of that, we have a really small output. We only have to go through all these commands which are basically SUIDs, and that's it. And we don't have to do much. That's the advantage of dev null, basically. Then okay, let me return here. So is the dev null part, and I think I discussed the other thing. The dot files were discussed last class only. Is the dev null part clear? Hello. What is the utility of terminal? That's what I showed you, bro. Basically, you see the amount of output that is coming out from this particular command. You have hundreds of permission denied lines, right? So what exactly are we supposed to do with these permissions, permission denied? I mean, that's useless for me, but it's being shown in the output, right? But the thing is, if we redirect the error lines to the dev null file, we'll end up with only the useful outputs. The errors won't be shown on the terminal at all. So as a result of that, we won't have to deal with that humongous amount of output that we get from the previous command. Now, the number of the number of lines that we have to deal with, the number of lines that we have to read, that we have to go through, has decreased drastically. That's the advantage of terminal. And yeah, of course, why would one like to redirect an output to terminal? Like we can grep out the useful lines too. Yes, you can do, but just tell me in a scenario like this. How do you know? How are you going to use the grep command? You have you have these files. You have a number of files. You have agent helper one, SSH key sign, Zord wrap. Just a minute. Excuse me. So, how exactly are you going to use the grep command? Because you have variety of outputs. I mean, you have a large number of outputs here. If you use the grep command, you'll have to individually write. And more than that, how will you know which of the commands? I mean, which of the you are basically searching for a particular output. I mean, you are searching for a particular file. You won't know the name of the file beforehand, right? You are searching for a particular type of file. You are not searching by the name. Remember, you are searching for only SUIDs in this case. So you won't be able to grep out. Do you understand me? If it's not clear, I can repeat. Clear? Okay. Yeah. Then and anyone else? I think this part is clear to everyone else. No one else has told me that. Okay. Let's proceed to the next part. So this is dev null. How much time do we have? 1824. Yeah, fine. Then we have etc password. Now, etc password is one of the really important files in a Linux system. Actually, there are a lot of important files. We are basically discussing. We are discussing these from the point of view of privilege escalation. The next sessions that we are going to have, I think it will be another Thursday only. They are going to be on privilege escalation, and I'm discussing all this from the point of view of privilege escalation only. I'll explain in the next session what privilege escalation is. A lot of you might know, but if you don't, it's not a problem. You don't have to know it right now. You can also Google it. It's fine. Uh, so I'm discussing all of this from the point of view of privilege escalation. So I'm discussing only the files which will be relevant for you when you are doing privilege escalation. I might be missing out a few files, but we'll cover them in the later sessions. Now we have etc password here. etc password we can do. Now, first of all, a lot of you might think that if I cat out the etc password, you'll get my password. The password. Some of you who have an idea about some of these files might have a misconception that the etc password contains basically contains the password of all the users, and if I cat out the etc password, you'll have the password of some of the users, and then you'll be able to remotely access my system. But that's not going to happen, because etc password is a file which traditionally contained all the passwords of all the users. Traditionally, it contained the passwords of the users. Nowadays, etc password is mostly readable to all. And in case what etc password basically has is a placeholder. There's a small x, you'll see right now, and that x basically tells the system to look for the password of that user in another file called etc shadow. I mean, Etsy shadow in the sense slash Etsy slash shadow. And we'll just have a look at Etsy password right now. Etsy password. As you can see, uh, there are a lot of users. I'll just enlarge it. So first of all, most importantly, there is root. Okay, and all these users, I mean, there are only few users with shell. Root is a user with shell. Okay, users with for now you can call the users with shell. You can consider them to be humans. I mean, all these users you can see a lot of users here. All of these are not going to be human users. I mean, all of them are not going to be people who are using this system. A lot of these are just system utilities, some daemons, and a lot of we'll have a discussion about those things later. So the people, the only users who you'll find inside the home directory, as we have discussed earlier, will have a shell like user bin zsh or something. So if you scroll down, you can see me, x117. This is me, and I also have a shell user bin zsh, and I recently created a new user called new user, and new user also has a shell slash bin slash sh. Okay, so first of all, let me just discuss about these things. This is the name of the user, that is x117, as you can see. So if I do a who am I, you will be able to see my name, and the terminal size is okay, right? I mean, the text in the terminal, that's visible. Yes, fine. A little, yeah. What? Oh, Arnab, you're there. A little increase will help. Okay, I'll just increase it. I think it's fine. Can you zoom in a little? Yeah. Is it okay now? Shantan Pal? Yes. Okay. Uh, okay. So, yeah. So you can see the user here. This is X117. This is me. And this X is basically the placeholder. This X tells the system to look into the Etsy shadow file in order to find out whether that user has a password or not. If that user has a password, then when I'm trying to log in, when I'm using the su command or anything, then it will look into the shadow file and basically use the use the information in the shadow file to basically check for the password of that particular user, and that's it. That's all it does. This X is the placeholder. Now the thing is, if you want to create a user, I mean, if you want to create a user directly from the Etsy password file, you can also do it. If you directly use the x117 thing and you just remove this X and instead place a password hash, you have to place an appropriate password hash. If you instead place a password hash, then that particular user will be created with that password. So even nowadays, even when Etsy password is not used as one of those as the command to, as a file to look into for the passwords of the new users. Even now, if you place a password here, if you place a hashed, a salted password here, I'll discuss what's a hash and a salt in this session only. And if you place it here, then you'll be able to create a user with that particular password. This 1000 is the user ID. If I run the ID command for myself, you'll see UID, user ID is 1000. The GID of that person is 1000. And I don't, these things are not that important. And this is basically the home folder, as you might remember, the home folder of that particular user. And this is the shell that that person will use when he spawns inside the system. So these are the important information to have. And one more thing is, if somehow the Etsy password, a readable Etsy password is not a vulnerability. You can read the Etsy password as much as you want, until and unless, as I told you, you have a user with the password directly set here, not the shadow file. You have a user with the password directly set here, then you'll be able to see the password hash of that user. Then you'll have to crack the hash. That's another story. But yeah, you'll be able to see the password hash of that particular user. Now, but if it's a writable etc password file, that might be a vulnerability. In some systems, what you can do is you can simply remove this X. First of all, if you remove this X, you'll get a no password user. For example, in Windows systems, most of the laptops that we have at home, we don't have a password at home where when we when we shut down and then we restart the system or anything, when we try to sign in, when we try to log in into the system, we normally don't have a password. So yeah, if you remove this X in some systems, you might get a no password user, right? So that's about etc password. Any questions? Great. Yep. Okay. That was a lot of information in a short period of time, so it might be difficult for some of you to follow. Any questions about etc password? Okay, I don't see any questions. Is it possible in Linux too that no password thing? Yeah, I think. Could you explain? Yeah, yeah. I'll deal with these two questions. See, in Linux, basically, if you remove that X, as I told you, in some Linux systems, not in all. I mean, I remember I was going through the privilege escalation scripts, and one day I just as a part of an experiment, what I did was I just removed the etc password, the X from my etc password file, using the using the vi terminal, I mean vi text editor, and somehow that system stopped working. I mean, it completely stopped working, and I had to reinstall VirtualBox and everything. There was a lot of trouble, but so it doesn't work in all the systems, but the placeholder thing, but in some system it works. What the placeholder does is, like if you have an X in here, right? You have an X. This X basically tells the system that this particular user has a password. So when I'm trying to, run a sudo command or something, sudo tackle or something, they want me to put in a password. So why do they want the password? Why are they asking me for the password? Why? Because they have tested, I mean, they have looked into the etc password file, and corresponding to the X117 user, they have found an X. That X means this particular user has a password. Now they are asking me for the password. Now when I put in the password, what what happens is, now the use of this etc password file is over. What it does is it moves to the etc shadow file. We'll soon be discussing etc shadow. After etc password, we have etc shadow. It moves to the etc shadow file, takes my password hash, compares the password that I put in, like it hashes my password, it compares it with the hash, it adds the salt and hashes my password and then compares it with the hash. If my password is correct, then only it will give me the output of this particular command. So the X is just the placeholder which tells the system that this particular user has a password. That's all it does. That's not the password itself. That's just the placeholder to tell the system that this particular user has a password. As I told you, in some systems, if you remove the X, you'll get a no password user. It won't look into the etc shadow anymore. It will just assume that this user doesn't have a password. In some systems, not all. Is the X placeholder thing clear? Yes. Okay. Okay. Next, we are going to move on to the etc shadow file. Now, this particular file, I won't be able to cat out for you, because if I cat out that file, you'll be able to see the hash passwords. Now, cracking a hash is another story. I mean, that might not also be possible, but in some cases, it might also be. So I won't take the risk. So if you do, I mean, if you try to cat out the C shadow, I mean, if you try to see what's the content of that C shadow file, you'll basically see I've created, I mean, I told you I recently created the new user, and for the new user, you'll get entries like this. I'll just increase the font size a little. Okay, the font size is not increasing for some reason. I'll copy it. Okay. As you can see here, uh, this is a typical entry inside a Etsy shadow file, right? This is one of the entries. Now I mean, if I do a control C and cat out, just Etsy password for X117. Okay, new user. I hope you all know what this command does. It just grips out the new user part of the. This is the new user. And as you can see, earlier on, when really old Linux systems, this particular password, this whole thing, this hash, I mean, between the first two colons, this part was present in place of this particular placeholder. So this part was used to compare the password of the user. Even now, if you try to, edit the Etsy password file and somehow create a new user with the password as this one, with the password as this particular hash, then you might observe that, that particular user works. You won't have to look into the Etsy password anymore. If in place of the placeholder, you directly place the password, you'll be able to create the user and use that particular user perfectly. So this is the password hash and salt and everything. I'm discussing what hash is. These are not that important. These are details about when the user was created and when the user was last logged in. uh, User can exist in the system. 9999 means like he or she can exist for as much time as he requires, and these details are not that important. What's important is this. Okay, so first of all, I'll just show you a particular site. Yeah, oh, Firefox. So uh, this particular portion in this file, I'll send the link. I'll send the link in the chat. And this particular portion is really important. What we have here is we have three parts here. The dollar signs, basically they separate the hash into three parts. What it does is the first part is the ID of the hash. This six is the ID, and the second part, between the second and the third dollar sign, this is the salt, and the third part is the actual hash. This is the actual hash. Sorry, this particular thing is the actual hash of the this particular user. This particular user. So first of all, the first part, that is the one or the two, whether you have one or a 2a or a 2y or a 5 or a 6. These basically specify what which particular hash the system is going to use in order to hash that password. One means MD5, 2a is blowfish, 2y is blowfish, 5 is SHA-256, and 6 is SHA-512. You might observe this one is 6, so this has been hashed using the SHA-512 algorithm. And then we have the salt right here. And after that, once the salt is over, you have the complete hash. Now let me discuss what the salt and the hash is basically. So first of all, the 6 tells you the algorithm that has been used in order to hash this whole thing. And the salt is something which is added in front of the password in order to hash. You might know that a lot of us, we don't follow the password protocols, and we just put in really stupid passwords like password 123 and everything. Now the problem with these passwords is most of the databases contain the hash outputs of these passwords. For example, if I have an MD5 sum of something like, I don't know whether this will be possible or not. Okay, I'll have to put in a file. Okay, right now let's not do it because that would make it longer. And what happens in this case is, first of all, we often put in passwords like password 123 and everything, and these passwords are really unsafe, because if you go to any site, any normal MD5 cracking site, to have these things in their databases, because these are the most common passwords: password 123, password admin. Like, these are bound to be there in any of the MD5 websites out there, any of the MD5 or any of the SHA-512 websites out there. So what we can do is, we can simply take the password and add a random string in front of it. Add a really random string. So your password turns out to be, the final password turns out to be, let's say, Q123RFC67 hash 12 password 123. That is the final password you have. Now this string is called the salt. So this particular string is known as the salt, and this salt is added in front of the password, and then this whole password is hashed. Hashing refers to converting the password into a particular format, which is, I mean, using a particular algorithm to encode the password, which is password or anything which is going to have a fixed length, really fixed length. I'll show you the fixed length scenario of hashing here. So we'll just have a look at two things. We're inside the session file only, and first of all, if I try to cat out process.c, cat process.c, it's a really small file, like it practically has nothing in it, right? So now if I try to generate a MD5 sum of this particular file, this is the length of the whole MD5 sum. Now if now you saw the output of this particular file. Now I'll show you a file which is going to be really long. So you might remember from the last session, one of the files that we had used there was rocku.txt. So this is the location of rocku.txt. Now I'll just cat out, I won't cat out the whole thing, I'll control C in between. I just want you to appreciate the size of this particular file, because it contains hundreds and hundreds of passwords. So if you're ready, I'll just press enter. There you go. I think you get an idea about the size of the file. I'll do control C. I've done control C, that's why we have and you can observe that we were not even over the A part, right? And we have passwords up to Z, even more than that, even numbers and everything. But we were right now, we were in the A and T part, and it took this much of time. So what we'll do is, we'll just try to generate MD5 some of the this particular hash. You might have observed it took some time, but as you can see, the length of the hash is the same. Okay, so that's one of the advantages of using a hash. So these hashes basically store the password. I mean, as you can observe, the length of the hash is same as before. I mean, same as the size of the hash when as the length of the hash when the file was really small. So the thing about hash is, one or two features that you have to look into is that the length is always going to be the same. Now, in case of MD5, the length is comparatively smaller, and SHA-512 has larger hashes. And the larger the hash, the more random it is. So definitely larger hashes are an advantage. Two or three things that you have to know about hashes is, first of all, if I go to the rocku.txt file, and if I change even one character, I mean, I just go to this A of Antilla and change that A to P or something, the whole MD5 hash will change. Nothing will remain the same. Like, if I'm creating an MD5 hash of a really large book, a dictionary, an Oxford dictionary or something. If I go to the dictionary, I change one character, the whole MD5 hash changes. That's one of the features of a good hash. It's called the avalanche effect, and you know what avalanche is. Basically, in snowy areas, if you shout or something, like, even a small vibration can cause landslides. I mean, the snow to directly fall down. So even a small change will affect the whole hash. Like it will change the hash completely. That's called the avalanche effect, and that's one of the features of a good hash. This uh, this particular effect has one advantage, because like you won't be able to guess. I mean, if you get a hash, something like you get all the characters same and only the last character different, you can't that won't ensure that you are really close to cracking the password or anything. You have to have the hash to be exactly the same as the password hash, otherwise it's completely wrong. So that's the advantage of the avalanche effect in general. And that's what you do with hashes. So what you do is, here the 6 specifies that it's using the SHA-512 algorithm. This is the salt that you are going to use. So let's say I'm putting in a bad password, any password 123, let's say. This particular salt is added in front of password 123, and then this whole thing is hashed. The MD5 hash of that particular, sorry, the SHA-512 hash of that whole thing is generated, and then we have the new user. So one or two things that, yeah, another thing that you have to know about the hashes, the advantages is, basically if I'm sending you a file and you think that that particular file is corrupted, some data is missing, or some, I mean, there's some change in it. So what I can do is I can generate an MD5 hash of my version of the file here. You can generate an MD5 hash of your version of the file, and we'll just compare the two MD5 hashes. If the two MD5 hashes are the same, then the two files that we have shared are definitely, I mean, 100% they are going to be the same files. I mean, there can't be any way they'll be different. So that's about hashes, and that's about the C shadow file. Is this part clear? Hello, anyone else? Hashes of two files can never be the same. I mean, yes, this is a good question actually. I mean, hash collision is a thing, and if the two files, I mean, if the hashes of two particular files come to be the same, then that particular hashing algorithm is declared as useless. So, I mean, in case of MD5, I think that that situation has arisen, but in most of the cases, MD5 is a very reliable hashing system. So it's not, so it's never going to, I mean, right now it's going to be in use. Just asking, do file hashes differ due to creation times, file names, and permissions? I mean, as long as that data is not included inside the file itself, and inside the, I mean, the, the binary data inside the file, I mean, that's not going to be affected. Yeah, no, just the content. Yeah. So that's the thing. That's about Etsy shadow. I'm sorry I couldn't show my Etsy shadow file. Actually, I'm not sorry, and I mean it's risky. If I show you my Etsy shadow file, you might have some ideas. Now we have the Etsy cron tab. The rest of the parts are not going to be that long, so I hope you have time. The Etsy cron tab file basically contains, Etsy cron tab is used to schedule some operations. So okay, this cut. Yeah, the Etsy cron tab file is used to schedule operations. I mean, I think a lot of you people, I mean, the first years or the second years, there's a really popular Python project, the Python notifier. I mean, whenever you get mails or something, that it checks your mails and everything. I'm sorry, I can't show my Etsy shadow file. It's literally, I'm sorry, you can't. Yeah, exactly. There is actually true. So yeah, that's the thing. If mm, yeah, what was I saying? for something about Etsy shadow, Etsy cron tab, right? Yeah. So Etsy cron tab, Etsy cron tab, yeah. I was talking about that project, right? Pi notifier. So what it does is basically it checks your, I mean, it checks your emails and everything, or let's say, yeah, it checks your emails and everything on a regular basis. I mean, on regular intervals of time. Let's say on regular intervals of times of let's say 2 hours or 4 hours or something. And if it gets any new mail or anything, it basically notifies the user. It basically tells the user that a new email has arrived. So what you are doing in this case is you are scheduling that particular program to run in particular uh, times. I mean, you're scheduling the program to, let's say, run. You're scheduling the program to run at 6 o'clock, 6 o'clock, then 10 o'clock, then again 2 o'clock, and so on. So the program, let's say, it runs 4 times in the day and hours of in intervals of 6 hours, and it tells you what the, I mean, whether you have any mails or anything or not. So this is basically the job scheduler of Python. I mean, of Linux. Cron tab contains information about all the jobs that you're going to have. So first of all, here, I mean, they have created the file really beautifully so that you can actually understand the whole thing. This is the minute, I mean, this is a table containing all the data. I'll just tell you how to read the cron tabs. And this is a table containing all the data. The first one is the minute, second one is hour, third one is day of the month, fourth one is uh, month of the year, and fifth one is day of the week, right? So the star means star is all. I mean, if you see a star in any of the cron tab files, it means for all hours. For example, you see a star in the hours section, that means all hours. When, I mean, all those, like the first hour, the 0th hour, the first hour, the second hour, up to the 23rd hour, every hour this will be run. Okay. Again, star, that means the day of the month, and so on. So basically, if you're trying to read this particular cron tab, this means this cron tab will be run every month of the year. I mean, every 17 minutes. I mean, every 17th minute of the hour, on every hour of the day, every day of the month, and every month of the year. So every single day, every single day and every single hour, this will be run on the 17th minute. Or in other words, this particular cron tab will be run on 12/17, 1/17, 2/17, 3/17, and so on. Similarly, if you see this particular cron tab, it will run every single day, every single month of the year, for every sixth hour, every 25th minute of every sixth hour. Or in other words, this will run. This is a daily cron tab, and this will run at 6:25. 6:25 means it's the 24-hour system. So 6:25. I mean, 6 p.m. would mean 18:25. So 6:25 would simply mean like this particular cron tab will be run on 6:25 every single day. For example, you have a weekly cron tab, and you have a 7 year and stars here. So every seventh day of the week, this will be run on 6:47. Seventh day would mean 0 or 7 is Sunday, so seventh day would mean Sunday. 0, 1, 2, 3, 4, that's Sunday, Monday, Tuesday, etc. That's, and similarly, this one is day of the month. Yeah, this one is day of the month. And so every first, this is the monthly cron tab. Every month, on the every first of every month, this will be run at 6:52. So this is the cron tab that you are looking at. And the last section is basically, this is going to run every minute of every hour, every single day. And this I wrote this particular cron tab for some later sessions. And yeah, that's how you read the cron tabs. Also, you have the path variable of this cron tab. So in case, for example, all these have I mean, these cron tabs have their full paths provided: user, sbin, and a cron. But in case the full path is not provided, for example, this is write.s. We are using a lot of programs like simply like I mean, we use a lot of programs like this, right? Like let's say sudo or something. I mean, just a minute. Yeah, let's say cat. We're using cat with that cron tab. It's perfectly working and everything. But the original location, if you try to locate cat, that's basically located in bin cat. This is actually the actual location of the cron tab. Let's say it's the same thing. So the actual location of the cat file is basically bin cat. But even if we simply use the cat command, we'll be able to run the whole thing. Why? Because the bin directory is inside the path variable. Similarly, here you have the path. What this path variable means is these path variables are just colon separated. So what they do is whenever they find a file which doesn't have an absolute path provided, they go and look in these locations: user local sbin, user local bin, sbin slash user slash sbin slash user bin. They will look in these locations in that specific order only. If they find a write.sh file in any of these locations, they'll run that file. Otherwise, this file won't be run. Is that clear? Yeah, I think you already know all that, bro. Okay. Yeah. So that's about cron tabs. I mean, so what cron tabs do is basically yeah. So cron tabs, what cron tabs do is basically they schedule your jobs, and that's it about cron tabs. And then we have Hcos. The Hcos files, they they just, I mean, I think it's a bit risky to show you my. No, actually, it just contains the normal entries. The Hcos file basically contains the named IP of a few of the locations. For example, let's say you're using something like ping, the ping command. I don't know how many of you know about the ping command. What the ping command does is basically it sees whether a particular server is up or not. For example, if I do a ping command on google.com, so since Google is up right now, I'll just get I'll see that the server is up, and it will be returning me outputs. And if I just put in some hypothetical IP address like 12.12.12 something, I won't be getting any outputs. I won't be getting any data returned to me because this particular server is not up. 7 packets transmitted, 0 received, 100% packet loss. So what ping does is basically it shows you which it helps you to test which servers are up or and which servers are not and everything. So what we did here is we use google.com. What happens in case for example, in case of a URL, when you type a URL on inside the URL bar of let's say Google Chrome or Firefox or anything, what happens is basically that particular URL has no meaning in the world of internet. That URL is sent to the DNS servers, and those DNS servers have not the URL. I mean the web. Let's say google.com. Google.com has no meaning in the world of the internet. I mean, this google.com is sent to the DNS servers, and the DNS servers check the corresponding IP to google.com, and they return this IP to the browser, and then then the request is sent to this particular IP of the browser, right? So that's how the DNS servers work. So in case, let's say in this case, you might have observed that ping, google.com, since google.com, there is a DNS servers which returns me an IP address with respect to google.com. We can directly ping to google.com. If there is no there is no DNS server entry corresponding to a particular IP, then what the system does is the system looks into the Etsy host files, and it checks for, let's say, uh, I mean, let's say for example, it checks the SCOs file for if I provide something like this ping, as I told you, some QWERTY or something. So it will go to the name of service not known. Okay, exactly, because first of all, this didn't even search the. This is not a proper domain, so they didn't even search the DNS servers. They directly searched the host. So if the HC host file had an entry corresponding to QWERTY, let's say QWERTY containing some IP address like 127.0.0.1 or something, then if we ping QWERTY, for example, right now the ping is not working at all. So if okay, we can add an entry, but yeah, that would take some time. I'll just do that. Okay, I need to do sudo ASC hosts. So I'll just put in the one and localhost only. Before we save the file, I'll just do QWERTY again. So sorry, not local. Sorry, QWERTY. I'll just try to ping QWERTY again. Ping QWERTY, and the name or the service is not known. So if I just if I try to ping QWERTY, now I'm successfully being able to ping QWERTY. Why did this happen? Because we named a particular host inside the SC host file. So what the SC host file does is basically it names an IP with a particular host. So for example, this IP is named as this one. So if I try to ping this guy, then I'll basically be end up pinging this IP. This is the IP for the home or the local host, and as the name suggests. And since I right now the Hcos folder basically contains the QWERTY entry as well. So the IP corresponding to this QWERTY is 127.0.0.1. So if you name a particular user, for example, if you name a particular IP to let's say google.com or something, the IP of google.com as some particular entry here, then you'll be able to ping. I mean, you'll be able to access the service using that name only, right? So in a lot of examples, I mean, if I name the google.com for even in the browser, let's say the IP of the google.com, if I rename the IP of google.com as something else and then I just type that in the browser, I'll be able to access google.com. So hchost is a really important file. I mean, I don't know whether I was able to explain the importance of hchost file or not, but yeah, it's what happens in case of hchost is basically it I mean, if you can rewrite, if you can overwrite the hchost file somehow, that can become a dangerous operation. I mean, in actually what hchost does is you don't have to remember the IPs of each of the servers, you rename these files. But if you have a writable hchost inside in a system where you are not the owner of the system or anything, that might be a risky thing. So is the hchost part clear? Anyway, yeah, anyone else? Okay. Oh, okay. So that's a Hcos. And bin bash, as I told you, bin bash simply helps you to just spawn a shell. So if I do a bin bash here, so I'm already inside, I'm already using ZSH. So if I do a bin bash here, I spawn a shell again. And similarly, if I do something like bin sh, again I spawn a shell. So that's, I mean, bin bash was discussed in the previous session only. So I'm not going into a lot of details of bin bash. Then you have the sudo's file. Sudo's file is another really important file. You remember the sudo command? the what the sudo command does is it basically helps you to run any files, I mean any executable with the permissions of with the security permissions of any other users. By default, that particular user is root. So if you do sudo some command, then you'll be running that command as root. And here you have the here about sudo as well. So if you do sudo then some command, then you'll be running the command as root. And if you do like sudo cat, as I did right now, sudo cat etc sudos, I mean I didn't have access to etc sudos normally. So what I had to do was sudo cat etc sudos in order to see the whole thing, because when I'm doing sudo, I'm basically running this command with the file permissions uh, of the root user instead of myself. So similarly, if I do something like this, sudo dash new user, that simply means I'm running this command using the file permissions of the new user. Again, this command will fail as expected because new user doesn't have access to these commands. So the etc sudoers file contains information about all the sudo events. I mean, sudo cat sudos, and let's just enlarge it. So it basically the hashes, you can just I mean go over these hash lines, because I mean these are basically commented out. These are not that important. Defaults you have. I'll come to this one. The parts which are really important is that here you have root all. That means root can run all the programs. Root has the, I mean, permissions to run everything. You know that root is the most privileged user in a Linux system. So root basically has the permission to run all the files and all the commands right here. And also you have, I mean, if you read the comment, it will be clear. Allow members of group sudo to execute any command. This basically means group sudo, and whoever belongs to this particular group will be able to run all commands. Now, as you can see, if I do sudo tackle, I mean, first of all, I for the user x117, if I do id in groups, you'll see one of the groups is sudo. So I belong to the sudo groups. That clearly means I'll be able to run all the commands. If you want to check, you can run the command sudo tackle. You may take notes of these. As you can see, I can run all of these commands because I belong to the sudo group. So the etc sudo file basically specifies which which users have access to which commands and everything. So in some cases, some users might also have access to commands without using any passwords. So sudo specifies all of these commands that you will have access to, that each of the users will have access to. Now I whatever's been discussed, I mean sudo tack, yeah, sudo tackle is basically, as I showed you, sudo tackle is to show you, I mean sudo tackle command basically tells you which command can be run by you as a user. So the sudo tackle, sudo program, we discussed these things, the vi previous, okay. Yeah, this part I want you people to listen carefully. This part is going to be a bit interesting. So the thing is, if you have access, let's just say for now, I mean, as you saw sudo tackle, when I'm doing sudo tackle, I basically have access to all the commands. I can run all the commands that I want. But let's say I am a user, I am a remote user in a particular system, and I I'm not supposed to have access to all the commands, but I have access to only one command. That is, let's say VI. VI is the text editor, as I told you. I sometimes I have to access a few really important files. So I can access. Let's say there is a particular file called in the session. Let's say this file, the basic.txt file or the process.c file, is, let's say, it's owned by root. And in order to, I mean, the permissions of this process.c file are set in such a way that no other user will be able to rewrite this file. But what the system manager has done is that particular system manager has gave me a permission to only edit this process.c file using the vi command, I mean using the vi text editor. So basically the only command that I can run in the system, the only command that I can run as the root user is vi process.c. Process.c, as you can see here, we are inside, and I can edit this particular command. Now, the interesting part about VI is VI, as I told you, is a text editor, and a lot of text editor have their own installed shells. I mean, for example, a lot of you might have used that one, the VS Code editor. VS Code, I think, has a shell option with it. I mean, you can run the I mean, you can run the terminal commands. VS Code has a terminal, so you can run all the terminal commands inside VS Code. So we have only seen the WQ command in order to exit out of the system and save the file. Now, instead of the WQ command, I'll show you an interesting command, which is sh. What vi does is, if we type this sh command, it generates a shell for you. So basically, okay, I don't think you'll be able to appreciate this until unless we are in a proper shell. So yeah, okay, I'll show you the next part, then it'll be clear. So now the thing is, right now we are running the command as I mean normal user, I mean as x117. So we don't have any access to anything, and right now we are who am I only. Now, as I told you, I'm considering the hypothetical scenario where I can run that particular command with sudo, I mean sudo, what was the command? Okay, okay, there's a new shell, right? Exit. Yeah. So vi process.c. Now let's say I have sudo privileges to run this particular command. So now I do sudo vi.c, and when I do sh here, I basically get a shell as root. So what I did here was basically, you can see root. I mean, you can see root here as well, but yeah, who am I is just to confirm that I'm root. So what I did here was basically I had access to only one command, that is vi process.c, using sudo. Now using that one small privilege that I had, what I did was I ran the .sh command, and since I'm running this command as root, as I'm running it with sudo, since I'm running this command as root, when I spawn a shell, I'll spawn the shell as root. Okay. Now, this part is really important. I mean, that will give you an idea about sudo in general. And is this part clear to all of you? This part is really important. And this is probably the only interesting thing that we did till now. Yeah, I know it's clear to you, bro. The others. Anyone else? The sudo part, I mean. Yeah, so to clear things out, because I'm running A as root, yeah. Exactly, you are running vi as root, so that's why when you spawn the shell, you'll spawn the shell as root. So if you were a I get vi shell as root, exactly. So if you were a low privileged user, you have basically escalated your privileges. We'll discuss about these things more in the privilege escalation sessions, but right now, let's just that was basically, I wanted to show you how sudo works basically. So if you simply do sudo bin bash or something, you'll be running bin bash using root, and that way you'll directly get a shell and everything. So that was prevesc env reset. Okay, we'll just discuss these things in the second path. I discussed the path variable, right? I mean, in chmo, when we were doing the cron tabs, we basically discussed the path variable. Uh, what the path variable does is, it has colon separated paths, colon separated locations. Any executable file which does not have the full path provided with it, they are looked for in these locations, And if any of the executables are found in these locations, then they are run using that the whole path. User permissions, we discussed ls-al in the last session, chown in the last session, chmod in the last session. Please confirm were these things discussed. Ch We have chown, chmod, and ls-al. All these were discussed, right? Hello. So yeah, I'm not discussing those. I'm not repeating those parts again. And yeah, first of all, the C shadow link I forgot to send it to you people. You can have a read through, and it might be an important. Like, I think it was covered. Uh, okay, what happened exactly? I mean, why didn't they send the whole link? I don't know, probably it'll work. Anyway, user permission. Yeah, then we have SUIDs. Now, SUIDs are basically files in Linux systems which can be run using SUIDs are files which basically can be run, as I told you, in case of sudo. SUIDs can also be run using the user's permission. I mean, using the permission, the security permissions of the file owners, basically. So, in case of if you have an SUID inside your system, and I mean, let's say we let's just convert the year into an SUID. CP in bash and root bash. So right now, do we have root bash? Yeah, we have root bash. So so what SUIDs do is basically and I see I mean ls stack layer of root bash liberatable. It's owned by x117. Now what we will do is chown x117. Oh, sorry, root 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 bash. What what happened? Okay, where did you? Oh, not permitted, right? Okay, that's go root bash now. If I just a minute. Says, okay, yeah, just switch my places. Root bash and show should be x117 only. Okay, now if I run dash p, yeah, okay. So what you can do in case of root bash, I'm really sorry. I should have created this file before the session started, and I apologize for the delay. And what happens here is, in case of root bash, I mean, if SUIDs, what SUIDs do is basically you set these are files with special privileges. you can run an SUID with the permissions of the owner of that particular file. You can run it with the security permissions of the owner of that file, owner of the SUID file. Now, SUID files have the SUID bit set. For example, if I do ls dash, right now, if I do normal ls here, you'll observe that this particular root bash is red colored, and if you have a Kali or an Ubuntu system, then this thing will be clearly visible to you. Now, this root bash is red colored because it's an SUID binary. Now, what I can do is I mean, in normal systems, when let's say you get root access, you get remote access to some system, these color coding won't be visible because you won't get a really a proper TTY shell or anything. So you can do ls stack la, and you will observe that the S bit is set. In the executable part, there is S. S means uh, S means it's an SUID. It's the SUID bit of that particular executable has been set. So a user who is non-root, I mean, for example, right now, even if I don't, if I'm not doing sudo, if a user who is a non-root user tries to run root bash, that particular user will be able to run root bash temporarily as root if they are using the dash p flag. I mean, not necessarily as root, they'll be able to run this particular executable with the security permissions of the owner of this file. In this case, the owner of the file is root, as you can see right here. So the security permission, I mean, when you run this file with the dash p tag, you'll be running this file with the security permissions of the root. So for example, if I run the file normally, you might remember running the file normally is this is just dot slash root bash. The dash p is just I mean, you know, that's not the. So if I try to run it normally, what I'm first of all, what is root bash here? What I did was I just copied the bin bash folder inside this directory. So running root bash is the same as running slash bin slash bash, and so running root bash should also give me a shell, just like bin bash does. So when I try to run root bash, I I should get a shell. So when I run root bash normally, the shell that I get here is a normal shell. It's the shell of the user that ran the root bash command. Now, if I just control C, I mean, sorry, exit out of the thing, and if I run the root bash command with tag p, and I do who am I again, you can observe that I'm root. Why? Because I ran the root bash, or in other words, the slash bin slash bash, with the permissions of the owner of the file, which is root. So this is the same as running sudo root bash. So if I just exit out of the whole thing, and if I do sudo root bash, root bash command, oh sorry, my bad. Uh, I, uh, I don't know why the shells are different like this. I mean, I don't know why they are doing it. But right now, if I run sudo root bash, as you can see, I'm root again. So this is the same as running sudo root bash. So whichever file has their SUID bit set, and you can run those files with the security permissions of the owner of that file, of the owner of that particular executable. So in this case, the owner was root. So when I ran the root file, when I ran the file, I basically ran the ran the whole thing as root, and since it was the executable to get a shell, so I got the shell as root. Is this part clear to everyone? If there's a doubt, feel free to ask. Anyone? Okay, move on to the next part. This was a SUID, and yeah, the cron tabs was done. Reading the cron tab files runs security. Okay, so yeah, that was a SUID, yeah, and that was it. I think we discussed the cron tab files, and that's that's probably it. That's it. That's for the session. And I'm really sorry, as I warned you earlier, this session was going to be theoretical, so parts are going to be boring. And so that's why I wanted you people to be a bit interactive. But yeah, some of you were interactive. Thanks for that. And the next session is going to be privilege escalation. Now, that's going to be interesting, believe me.